So for question number 6, we have a situation here where we have a horizontal spring on a block, and the block is the block is compressing the spring of 0.20 meters, and then it's released. It goes 1 meter, right? And they tell us that the spring constant is 200. The spring constant K is 200, and then they're asking us what is the coefficient of the kinetic friction between the block and tabletop, right? So they're asking us to find the kinetic friction, the coefficient of the kinetic friction. Okay, so to find that, we have to find mu basically. We know that the work net is equal to the change in kinetic energy. Now the work net is going to be the work of the spring plus the work of the friction. And the work of the spring is going to be half of kx squared, and that's because of basically almost like a base times height sort of thing that happens, and it gives us to kx squared. And then we have the work of the friction. We already know it's going to be mu times the normal times the distance, which we're going to say is s. And then we have the change in kinetic energy. Now the change in kinetic energy is going to be equal to 0, right? And then after we equal that to 0, we start basically solving for mu, right? You move this to the other, this to the other side, this one right here, move it to the other side, and you start solving for mu, and you end up getting that mu is equal to half of kx squared over mgs, right? And you plug in the numbers that they give you, the 200 over the 2 and the of course the g times the 5, and you should get around 0.2. Mu is equal around 0.2.